We are now going back and going to section 8.1. So we started with 8.5 and 8.6 because I really wanted to give you the picture of what we are dealing with. So we are dealing with these quadratic equations or quadratic functions, which graph parabolas. So in the first two videos, we explored what a graph parabola looks like, some features about it. In 8.6, we talked about how to find the vertex. And now what we're going to move on to is finding the x-intercepts. So a quadratic equation is anything that has the highest exponent of 2, and when written in standard form looks like this. So ax squared plus bx plus c is equal to 0. Now what we're going to be doing is kind of going back to what we did in chapter 5, which is learning how to solve these quadratic equations. But we're going to add on a little bit of understanding to this. So you're going to be finding the values of x that make this equation true. So the values of x that make this function equal to 0. Now, the connection is that in 8.5 and 8.6, we were looking at quadratic functions in this form. Now we're looking at quadratic functions in this form. I should put the a in there, sorry. Ax squared plus bx plus c. So what changed? Well, we set f of x equal to 0. Well, what is f of x? F of x is equal to y. So we're finding the values of x when y is 0. In other words, we are finding the x-intercepts. So when you're solving a quadratic equation, you are finding where your graph crosses the x-axis. So we already know how to find the vertex, and now we're going to be able to solve for these x-intercepts. Now, just to be complicated, x-intercepts are called x-intercepts, right? That's a nice obvious name. They're also called zeros because it's what makes the equation equal to 0. And they can also be called roots. So if I ask you to find the x-intercepts, the zeros, the roots, or sometimes you'll be asked just to find the solutions for a quadratic equation, it's all asking you to do the same thing. Now, in chapter 5, we did this by factoring. We used the zero factor property. But that won't always work. Not every quadratic equation is factorable. So in this chapter, what we're going to move on to is 3 more methods for solving for these x-intercepts, zeros, roots, and solutions. So let's start with objective 1. Objective 1 is just reviewing the zero factor property. When are you going to solve using the zero factor property? When it's factorable. So if you come to a quadratic equation that's factorable, this is probably the easiest way of solving, not only because we've already done it, but also because it's just this process that it's because it's a process that we're used to doing. So here's an example. If I'm going to solve by factoring, you're using the zero factor property. What that means is the first thing you have to do is set it equal to 0. So you can see here we've subtracted 16, done. Then you have to factor. So you're going to factor x squared minus 16. You're going to recognize there's 2 terms, and then it's a difference of 2 perfect squares. So we're going to factor it as a difference of squares. So x plus 4, x minus 4. Now to solve it, you're going to set each factor equal to 0. So what makes x plus 4 equal to 0? When x is negative 4. What makes x minus 4 equal to 0? When x equals 4. So these would be my 2 x-intercepts for this function. So what if I gave you this one? So if I said, hey, solve by factoring, don't forget the zero factor property. So step number 1, set it equal to 0. So to do that, we are going to subtract 180 from each side. Then I'm going to notice a greatest common factor. So I'm going to greatest common factor out this 5. So I'm going to be left with x squared plus 9x minus 36. Now, just mentioning this here, we are not dealing with expressions here. We are dealing with equations. So if you wanted to, instead of greatest common factoring out the 5, we could have actually divided each side by 5 and then gotten rid of that 5 altogether. Because there's no variable attached to it, it's not going to have any effect on my solution. If you're nervous at all, just leave it, because sometimes you can get rid of it and sometimes you can't. Sometimes it matters, sometimes it doesn't. So if you're nervous, just leave it in there. So I'm going to keep that 5 in there. Then I'm going to factor this. So I'm going to notice that it's a trinomial. So I'm going to factor using the AC method. I'm going to look for two numbers that multiply to give me -36 and add to give me 9. So I'm looking through my list. I've got 1 and 36. That won't work. I've got 2 and 18. I've got 3 and 12. So if I do a +12 and a -3, that's going to multiply to give me -36, and it's going to add to give me +9. Now, you can do this using the AC method, or our decomposition method, or because you notice that the leading coefficient is a 1, we could just draw our two brackets. We can put in x + 12 and x - 3. Again, if you want to do the whole decomposition and then grouping, that's awesome. But after chapter 6, hopefully you're getting used to factoring trinomials and trying to do them a little bit quicker. So now that we've set it equal to 0 and we've factored, now we're going to set each factor equal to 0. So we've got x + 12 equal to 0, and we've got x - 3 equal to 0. So this would be x is equal to -12. This one would be x is equal to 3. Now, some of you might be thinking, what about this guy? It is a factor, but what would make 5 equal to 0? Well, we can't. That's a contradiction. And so there are no solutions because there is no variable. The x doesn't exist there. So there's only two x-intercepts. And for every quadratic equation, you can only have up to 2 x-intercepts, because think about the shape. No matter how I draw it, the maximum number of times that I can hit the x-axis is twice. Now, you could also just hit it once, and you could hit it not at all. And we'll talk about that in a couple of videos. Okay, but for this one, we're going to say that our solution set is -12 and 3. All right. I'm going to try to do a better job at taking breaks. So after objective 1, you should go and try some questions in the textbook. So just a quick looking at the textbook, I see that you can do questions 1 through 9. Go practice them. Go take a break.